Hey, what's up, guys? Chung here, and today let's take a look at this LeetCode problem number 335, self-crossing. I can see why a lot of people don't like this problem. But still, I have my faith. I like this problem. Yeah, I'm gonna be the minority here this time, even though it's not an easy one. That's why it's marked as hard. Okay, enough talk. Okay, you are given like an array of numbers here with integers here, and each number represents a direction, like the length of direction you're going to travel. And it starts from going up. Always go up, and the next one will be left, and the third one will be down. Okay, and the fourth one will be right. Basically, you're going counterclockwise. You're going this way. Okay, right. You're going this way. And the length of the integer is not it's not fixed. Basically, these things can go on and on for like a very long time, and it asks you to find if there is a crossing, if there's a self-crossing in this sequence here, and write a one-path algorithm with O1 extra space. Okay. Hmm. Yeah. So and here it gives you a few examples here. For example, this one we up in go up by by length two, and then we go left by one, we go down by one, and then we go right by two. Okay, so here is the self-crossing. And example two here is we go up, left, down, and right, which there's no self-crossing. Here, yeah, if they're the same, it's still counted as a crossing because they will be stopped at the same point here. Okay, so how can we think about this problem? You know, we cannot we cannot come up with a solution without doing some experiments, right? Basically, let's try to figure out how many possible ways of self-crossing. Okay, here is already giving us one example here, right? So basically, go one, two, three, and four. Okay, so basically, these things means that uh let's say the current one is I, okay? So I is self-crossing with I minus 3, right? So this is this is I minus 1, this is it's minus 1, I minus 2, and I minus 3. So this is one way, the first scenario, okay? Then what's the second scenario? Second scenario is this like this. 1, 2, 3, 4, and 5. Okay. So in this case, this is I self-crossing with I minus 4. Okay. How about the third one? The third one is this. 1, 2, 3, 4, 5, and 6. That's I. This is I cross with I minus 5. Okay. I'm telling you, there's only three ways of three patterns of self-crossing. But someone must have a question. How can you be sure there are only three ways, three patterns, three scenarios of self-crossing? We can do some like simple experiments. Let's say we keep doing it. Let's say, how about this? There's like this 1, 2, 3, 4, 5. Okay, how about this, right? Now someone say, okay, so now this one is like, this one is I, right? So this I is crossing with what? With the I, it's also I minus 4, right? Okay, I minus 3. So this is I minus 1, I minus 2, I minus 3. This is I minus 4, okay? So in this scenario, it's also like minus I minus 4. As you guys can see, as long as the last I is crossing with the I minus 3, this is can be all categorized into this scenario here. Okay. Same thing here, right? Let's make more drawings. Let's say there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How about this, right? If we have this one here, right? So this is the example like, mm, what's the so this is I, okay, right? This is I minus 1, I minus 2, I minus 3, I minus 4, and this one is I minus 5. So basically this one will become the same pattern as this one. So why is that? Because for the I minus 6, I minus 6, I minus 7, and I minus 8, it doesn't really matter, right? Because they are not crossing to each other. So we can simply like ignore those things. We only I think basically uh, the observation here is that we only care about like how many which is the line the last one will be crossing with. I think no matter how many lines you draws here, there will be only 3 patterns. Let's say if we like match uh with this line here, right? So this is I and this is I minus 1, minus 2, minus 3, and minus 4. So in this case, these two are the same, right? Right. And I can draw a few more, like say 1, 2, 3, 4, 5. Here. Uh, 1 here. Okay. How about this? Same thing. I think this is the same as the I cross with I minus 5 because this is I minus 1, minus 2, minus 3, minus 4, and minus 5. Yeah, but you can just draw as many possible crossing patterns as you like, but I'm telling you, there's only 3 patterns of drawing. Either cross with I minus 3, or I cross with I minus 4, or I cross with I minus 5. Yeah, it depends on like which line this I is crossing with. We have 3 patterns here. Okay. And since we have these 3 patterns here, we can just simply separate those 3 patterns, and we do a if check for each of the patterns whenever we have a new numbers. As long as any of the patterns applies, then we return false. Otherwise, in the end, when the for loop finished, if none of the condition have ever matched, then we return false. Okay. I hope you guys can understand that. Okay, now, okay, so what I'm trying to do here is like the n equals to length of the x, okay, and then we do a for I dot in range. Okay. 3 plus n. So why I'm doing 3 here, right? Because it's zero base, right? And if it's less than 3, then we know it's not possible to be self-crossing. Okay, so we start with 3 here. Now, and in the end, we simply return the false here. Okay, so now the first condition. Okay, first condition is this one. 1, 2, 3, 4. Yeah, basically this one is I is crossing with I minus 3, right? So that's the first case. Let's do some observation here. So what's gonna be the observation of this? So mm, this is I, right? Minus 1, minus 2, minus 3. So the only thing we care is that we use the two lines facing to each other, right? That's the most important thing we need here. And for this case, if, right, if the xi is greater than the xi minus 2, right? And what? And the xi minus I minus 1 is smaller, right? Smaller or equal than the I minus 3, then we return true. Makes sense, right? Basically, if this line is greater than the I minus 2 and this I minus 1 line is smaller than the I minus 3, then we know there must be a crossing here. Okay, so that's the first case. Now the second case. Okay, so the second case is this one. 1, 2, 3, 4, and 5. Okay. Yeah, I think this is the second case is the one that's most likely will get overlooked. So basically this one is I crossing with I minus 4. Actually, this is one is even easier, right? So for this, in order for this to happen, right? So I'm sorry, this is I minus 1, minus 2, minus 3, and minus 4. So for this case to be happen, first thing is the I minus 1 and I minus 3 has to be the same. Basically, if the I minus 1 is equal, right, to the I minus 3, okay, I minus 2. And what? And the xi plus xi minus 4 is equal to the xi minus 2. Then we return true here. Basically, if these two lines are the same as the minus 2 and yeah, actually it's not even equal here. I think it has to be uh I mean, this one can be longer, right? I mean, maybe we should use like greater or equal than that. Okay, basically this I, as long as it can reach it can be can reach the last point of the I minus 4. It's this I can be longer, right? This I can go all the way up here, right? But it's still it doesn't really matter. It's still like like crossing with the I minus 4. Okay, and the last one is this. Last one is 1, 2, 3, 4, 5, and 6. Okay, so this is the last case. If x, so what's this case? That's the I here. Minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, So how many conditions we need in this case? Uh, let's say I think the first condition is the first one is this, like the I minus 4 plus I should be greater than the I minus 2, right? So that's the first condition. Basically, the I plus X I minus 4 will be need to be greater than the I minus 2. Okay, so that's the up and down. How about how about the left and right? Uh, so left and right is the let's see. Yeah, so for left and right, it's this basically the X I minus 1 plus X I minus 5, right? Has to be greater than the X I minus 3. Okay, and yeah, and what else? Yeah, and there are two more conditions. Basically, X I minus 2, I mean, has to be greater than the X I minus 4, right? So basically, this two has to be greater than 4, and same thing for the left and right. And X I minus 3 has to be greater than the X uh, I minus 1. Yeah, and then we return true here. Oh, one more thing here. Since we have I minus 4 here, we need to add like this. If I is greater than 4, right? Then we do this. Otherwise, we'll have like a index exception here. Same thing for this, greater than 5. Then we do this. Okay. Yeah, I think that's pretty much it is. Let's try to run the code. Okay, so the test case pass, submit. Yeah, so it's passed. I mean, I would say it's like a math plus observation problem. That's why a lot of people don't like it. And yeah, basically, as long as you just need to figure out. I think the key idea for this problem is that you just need to draw a few as many scenarios as possible, and you should only care about you should notice that like how many ways the current eye can be crossing the previously lines. So if you draw uh, enough di- diagrams here, you should be able to notice that there are like only three possible ways. I cross with I minus 3, I cross with I minus 4, and this one, yes, I cross with I minus 5. So those are the only three possible crossing scenarios. And with these scenarios, I think it's not that hard to come up with these three if statements. Okay. Yeah, that's pretty much I want to talk about for this problem. Yeah, I hope you guys likes the video, and yeah, thank you so much for watching the videos, and stay tuned, guys. Good night. Bye.